Lack of adoption of units of measurement libraries, survey and anecdotes by Omar Salah and Steve McKeever. So what we're interested in here is assessing the use of libraries for adding unit of measurement support to conventional programming languages. In a previous study, we classified unit of measurement libraries found on open source repositories. And a simple search found over 65,000 projects, of which 3,700 were actively developed libraries. And by further filtering, we arrived at 82 that represent the most prominent and covering many programming languages. And we postulated there that too much diversity, lack of code sharing, and duplicated efforts were discouraging adoption. We did a further study, and we found that they all implemented a version of the quantity pattern, so a very concise representation of units and derived units without large class hierarchies. But what was remaining was understanding why there are so many and why they don't seem to be used. So our study was divided into three phases. Firstly, we interviewed developers and complemented that with a survey of practitioners. From there, we extrapolated factors, and then we produce a set of recommendations. So our study involved 4 interviews, 1 physicist at Uppsala, 2 Java unit developers, and 1 functional programmer, along with the survey that had 91 respondents, mostly developers, but some team leaders and some managers. So factors behind the lack of adoption of unit of measurements are listed here. We've grouped them into 3 categories: ignorance and apathy, technical internal factors, external factors. These are reasonably straightforward. There's nothing new here, but please do look at the paper to find some interesting quotes in each of these categories, as they reveal some of the subtleties that are problematic. Our technique to extrapolate the factors used qualitative coding, and every factor is a theme, and a theme was deemed significant only if it was repeated as a concern between different interview subjects and questionnaire respondents. So if we look at the first one, ignorance and apathy, ignorance was a major reason people do not use unit of measurement libraries. They just do not know that these things exist. There's also a lack of concern and indifference to using a solution, especially if it's a new solution, so that there's not a clear gain for many groups. There is also the cost factor that each annotation takes up to 2 minutes. This is from another study. So there's a feeling that these libraries could cause even more harm than they profess to solve, even if that's unjustified. There is just that feeling. There's also a lack of familiarity, but this applies to any kind of new usage of a library. They're not well known, and also there's traditional factors. If your group does not use them, why would you go out on a limb and use them yourself? So there's very little incentive for change. However, more importantly are some of the technical internal factors. So these hold people back because there's no perceived return on investment, or it seems to be low if you don't have too many problems so far. There's this overhead of using a unit of measurement libraries. And then there are some technical, real physical factors such as runtime unit handling. Many respondents felt that unit of measurements are purely compile time constructs, but there are those who want them to be at runtime. They want their input to be a meter, a kilometer, a mile, and for the code to work properly in that kind of situation. Once you have that, then you have to have boxed values at runtime. You have to do your checking at runtime, and that will be a huge cost on performance, on speed and memory. Also, very few of these libraries do any effort in optimizing their conversions. So converting between different representations will incur runtime errors, and they will accumulate, especially if you're doing large computations. Interestingly, there are some unit libraries, even some popular ones, that struggle with complex derived units in order to do equality and checking. So this is also deeply problematic. Moving away from these kind of technical internal factors, you've got external factors, and this is, I think, is one of the most important ones. The cost of porting existing working code to communicate with unit of measurement libraries is a major challenge. So there's no point in having units in your programming language if your database doesn't support them. You have to think of the whole ecosphere. And at first glance, a unit of measurement library might seem easy to use within a project, but once you look at the inner workings and you look at the interfaces you need to your other modules or components you have, then you incur a great cost. It doesn't necessarily fit in very easily. So from this, we have some design suggestions for unit libraries. Again, there's nothing really surprising here. These libraries have to be simpler. They need to have syntactic sugar or support of an IDE. You cannot expect users to adopt this generic style object-oriented programming, which has seemed to be very clunky. They need to be idiomatic. They need to follow the language. They need to provide meaningful error messages. The line number needs to be where the error is rather than 1,000 or 100 off. And you need to be able to deal with flexible types, doubles and floats. They need to work all together. So this kind of leads one to the following conclusion, that the design suggestions for unit measurement libraries need to make sure that the types can be as easy to use as arithmetic types. Now that's very obvious, but is it achievable? And is it achievable in the context of the competition, namely component-based unit checking, where you've got checking only at the interfaces. So you've got groups that might be working on a very small scale, a very large scale, and only when they work together do you actually do unit checking. That's a very lightweight approach, and there's very exciting work being done there. Obviously, languages such as F# have very powerful inbuilt support for units, and that allows you to kind of create your own versions on top of that very elegantly. Or alternatively, you've got unit testing. So within this various four approaches, it's not clear what the advantages and disadvantages of each are for developing scientific code. And this is where we need to do further work. Thank you very much.